Okay, now we will try to implement our transition diagram. Okay, with some code. Then, now, how we gonna actually do this thing? Simple thing would be to understand this transition diagram. Whatever transition diagram we have, they can be implemented with the because there are multiple decisions to be taken. So switch seems to be a kind of good choice for all these things. Now, if you see, we need to go from one state to another state, so that will be the states of a switch, right? And we need to remember our state, that we will have a variable called state, which will remember in which state we have. And if you see, we are trying to return what is here is a token. Okay, the token then will be a kind of class. So token will be a class which has you know a token is a class in a C plus whatever you have, which will have two things in it. One is the name and second is the attribute. So whenever you are trying to return the token, you are actually putting stuffing two things into it. One is the relop, which will go with the name, okay, and second is the attribute value, which can be in this case the six um, relational operator of one of the six relational operators. That will be the attributes in this. Okay. So our token will be a class with a pair consisting of token name and the attribute value. So we have to understand this thing. So we need a method basically, uh, which will do what? Which will return the token and which will have the switch statement in it, which will try to execute a particular state on the basis of the input, right? So we have these states. For example, if we in a state 0, if we have a less than, we scan characters, and if it's less than, on that less than we will have to see what is the next character, and we have to stuff it back into the input as well if it is not. For example, if it is equals after that, so I'll say I have to return my method. So for example, I have a method called get relog. In this case of this is a get relation operator, or RELOP is my method, for example. I will call that, and this method has to return a token at the end of the execution of the transition diagram. For example, this one, I have to say which relational operator it was, if it was at all in the input. So this get relog will have a token as a return type because it returns that object. Okay, so that code I have actually taken from the Dragon book, the most famous book we have on the compiler design. So this is the same code. I'm saying I'm actually extensively using the Dragon book, and I'm trying to teach it from that only. Okay, and many other books and many other things, but uh, more and specifically if we talk, it's the Dragon book. Okay. Now this is my method get relog, and it will return the token. So at the end of the transition diagram, we have to figure out, which what I have to return, right? So I will return a token, which has a couple of things in it. The first thing will be I create off-type token an object called return token, a new object, and I initialize its first um, value, first component, because there are two components. The first component will be initialized with the relog. That is a code for the relational operator. Okay. Now then I run an infinite loop. Okay, so if I'm saying while one, so this is gonna run forever. So unless it doesn't break, so from this loop some way. So for that, we have to see if it does not have a legs in it. So it will break two ways. One is that it identifies a particular token. Say for example, it has identified less than equal to in this case. Okay, or what else happened to the pen? Something. Okay. less than equal to, or less than or not equal to, or whatever it is. So on that, if it identifies that, it will can run out of this, or it may come from out of it if it is not at all the lexem. If it's not even the if it may have some errors. For example, after less than sign, it may have something else. And so we have to understand that it is a less than, then it will return the LT, or there may be some failed situations where to come out to see that. So if you see this code, so in a while statement we have a switch case and it has a state, okay, whatever the state it has. So initially the state will be 0 because this is the first start state, so we will pass our state value will be 0 in this case in the beginning. So case 0 will run, and what will happen here is we will read an character from the input and put it back into the C. Then if I see if C is equal to, compare with the less than, if it is so, then I make statement my state as 1, right? If this is less than, my state will become 1. Okay, but it may not be less than, it may be equal to. Okay, then my state will be equal to 5, as you see here. If it is equal to, the state will become 5, because this is then the is equal to. Excuse me. Okay, or if it is maybe greater than, then state will be 6. Now firstly we will have less than or equal to or greater than. On that basis I have to make my state 1, 5 or 6 from 0. So my state here is gonna be 5 or 6 or 1. Else, if it is not, for example, neither is less than or equal to nor greater than, that means that this transition diagram has no meaning for it. Then we go to the what's called the method called fail. That means our lexem is actually not a relational operator. Now what will fail do here is, it depends upon the lexical analyzer, what kind of method function we do for it, because if we enter the fail, that means it's not a, the lexem is not a relational operator, it may be something else. So we have to actually execute some other transition diagram. Okay, so the fail depends on a global error recovery strategy of the lexical analyzer, right? Okay, it's quite simple to visualize what fail must be doing. So anyways, if with whatever our state was it equals less than, or was it equals to, or was it greater than, accordingly my state variable will hold either 1, 5 or 6. So it will break out of the case 0, and then it breaks out of the switch, is it? Then it comes back, the while will not leave it, while will start running it again, and this time state will not have a 0. Say for example I was having a greater than sign. Okay, now if I have a greater than sign, then the state will be having 6. So this time a state variable will be having a value 6. Okay, there's some problem with the system. So okay, anyways, so what I'm saying is, if now the state is 6, that means it will execute the code of case 6 somewhere here, right? Now what will be the code of 6? Because after I have scanned the 6, I have to see what is the next character, right? So again, in the case 6, we'll be having in a C get character like we had here. C equals next char. So I'll be having same thing. C is equal to next char, and then a chuck. If C is, I got a couple of chucks here. If C is equal, C is equal, then I got to say state 7. If it is something else, that means it's not equal to or anything else. I would say else. So the code 6 will be simple. But if C is equal to state equal to 7, else state equals to 8, because here I have already when I'm on a 6, that means I have already scanned the greater than, so it is greater than. So I have to see now, is it simply the greater than only, or is it greater than equal to, right? So my code will be simple, that say if and else, and in if I make the state 7, and in else I make the state 8, right? So simple. If I write it here, somewhere downside. Okay, if I want to write my case number 6 here, so consider these, forget about these and just concentrate on a case 6. So I will have C equals to next character. So now I scanned one of the inputs. Now I say if C equals to is equal sign, then state is gonna be what? 7. Else, if it is not, if it's anything else, whatever it is, then that means it is not greater than equal. It was only the greater than. If it is something else, then I say else state equals to 8, right? Then I'm going to make this statement 8, and I break out of this, simply break out of the case 6, right? Okay, from this case 6. Now, say for example, when I scanned, and after the greater than, let's say I had a greater than. Now here, when I scanned, the next character was not equal to, it was something else. Maybe it was a space, maybe it was something, a character, maybe a digit. That means my input, say for example, my input was 4, then less greater than. I had reached it to the greater than because I'm on a state 6. Now after that it is something like 7. It's 4. It was trying to see some piece of code if 4 is greater than 7. Now I have scanned the 7, so that means this is the greater than sign, okay? But I have scanned the 7, so that's why I'm gonna state 8, because it was not equal. I have scanned it, and my state is it gone to the else, so state is equal to 8. Now it will not come out of the while loop. It will break out of the switch and come while we'll run it again. And now this time around I will have a state 8. Okay. Now in a state 8, the simple thing is I have scanned one extra character here because I have scanned the 7, which is not part of the relational operator, because the relational operator is greater than only, right? So I have to, send this back. I have to retract. That's why it's a star on the 8. I have understood that I have understood the lexem, that it is a token, that it is a greater than lexem. So I generated a token. I will return it the relog. That I understood that's a relational operator, and it is the greater than, right? But I have scanned the extra character, in this case 7. So I don't have to throw it off because this is used to generate the next lexem. So that's why I have to do something. What I got to do? I got to retract. So I need to have a function or a method called retract. Okay. So what will be that retract method doing? Simple as it. We got to put that input character, that 7, back to the input stream. How are we gonna do that? It's very simple, because whenever we are scanning letters, we have put that in the buffer. Say for example, it was 4 greater than 7. It was like that, right? And I had an input pointer. If it was pointing to this, then I scan this. My pointer is here. Okay. Now after scanning this, my pointer is now ready for this guy. But it should be back to this, because this is not the character used. This is the extra character, so I have to retract. So what I do simply is my retract will make this pointer one step back, so my pointer will be on here, so as if it was not read. Simple as it is. So retract, this is the case 8. The retract will do what? It will first make a ret token. What is ret token? Ret token is the object of type token, because I said my token has two guys in it. One is the name, and one is the attribute value. And I have created object of this class called ret token, return token, or whatever. So that Now if I want to access these members of this token class, then I have to use the object of the token class, that is the red token. So I'd say red token dot this and red token dot this, right? So that's why I'm saying here red token dot attribute, because so attribute is this guy, right? This is the attribute. So I'm putting into this the greater than sign GT. How I will access this? Object of the token called red token dot attribute. So I'm actually putting it into this something. What I'm putting? GT, because I understood that it's a greater than sign, simple as it is. It is saying GT because we have understood it's a greater than sign. Then I will return, and in the beginning, if you say now what will be in the first one, the name guy. In this we already have a relop, okay, because we have relop in the beginning. We have put, when I created the object, I put it in the first relation operator, because I was because to run this relop method, that is to run this transition diagram of the relation operator, I was sure that it is gonna be the relation operator. So I supposed that my relation, one of the 6 relation operator would be there. So I initialize that upfront, and in the end I don't have to initialize. If you don't do it in the beginning, then I have to do it. I have to do it here. Red token dot name is equal to relop. I have to do that thing also. But we have done it upfront, so now we have to only initialize the red token attribute according to whatever case I was having, right? And then I will return that red token that will be returned to the method who has called that, right? Similarly, we may have the transition diagrams, implementation transition for other things, okay, other transition diagrams. So we will have the same switch codes for everywhere, wherever we like, and that's quite simple to understand, and quite simple to imagine as well. You can have all these transition diagrams as a one transition diagram, where then you have to actually do what? You have to this start symbol is 9, and here is a 12 in this case, and here is a 22, and here is the 0. You have to make it 1, and then have a branch, and then you can have one big switch statement which is running everything, right? Now if we try our hands on this another diagram where there is a letter and there is a digit, okay, so in this case we have the state 9. If the state is 9, right, so my switch case will be kind of like this. Okay, here, so it will be again return token type, token, and all those things. And while 1, I'm talking, I'm again in the while 1 loop, okay, that is above loop, okay, that's already running here. That's a case 6. Now let me continue this as a case 9. If there is a case 9, okay, I will do what? C equals to next char. So I'm scanning one of the inputs, and I'm saying if is letter C. If the C is a letter, right? If C is a letter, then what am I gonna do? Then I make my state equals to 10, isn't it? If I see the diagram properly, if it is a letter, the input character is a letter, then I got to go to the state 10. And after that, if it is a letter or a digit, then I may go to the state 11. Okay. Sorry, I will go to the state 10 only. Here, if it is a letter or digit, if it is something else, then I go to the state 11. So that means I'm saying, firstly, if it's letter, make it a state 10. Okay. Else if is digit C, if the C is a digit, so letter or a digit. Actually case 9 will not be, because on the case 9 I have to go for a say for example state 10, then I'm gonna break, because I will not say else if, I will say in fact, say for example it was not a digit, then I have to call the fail, right? Like here, here, like would you fail here because lexeme was not actually the character, so I have to say state equals to 10 here, and then I will say else, call the fail. That means the guy uh, we were talking about is not an identifier, because we're trying to figure out is it identifier or not. So for identifier, the first letter should be a letter, then after that um, it goes to state 10, and now it has to see uh, whether the next character is letter or digit or something else. So that means we need to have a case 10, is it? So in case 10 we again c is equal to next character and try to see if, because on case 10 we will try to see is it a character or a digit. Okay, anything you letter or a digit, no problem. Okay, on the 10, so it will stay on the 10, we have to understand that. But if it's something else, then go to the 11 and we have to also retract. Okay, so that's what we want to implement here. So if I'm saying is letter, this C which we have read, then yep, then we're going to make state, because if it is letter, no problem, stay on a 10. Else if is digit, if it is a digit, what are you going to do? Just tell me. What will make our state? If it is digit, yep, you still be on a 10, right? Because because if it is a letter or a digit, because if we are on a 10, that means we already scanned that it was a letter from the 9, because 9 makes my state 10. Okay, that means my character, it was a letter, that is why I'm on a 10, right? Now when I'm on a 10, I will see is my the character, next thing, a character or a digit, no problem, we can have it. Okay, you can add up the underscore as well, no problem, if else if it's an underscore, or you change the definition of the letter as a to b a, because we can change our definition of letter from a to z and small a to z, as well as the underscore, right? And then it's not a problem. So if it is a letter or a digit, it is still a 10. But if it is something else, okay, then what are you going to do? Else you will make your state as 11, is it? And then you break. Now on 11 you have to retract, okay, like we did here on 8, you retract and you return that you say that token dot attribute equals not equal to gd, but what you do is you will because this time it is an identifier, so you make it an id and you return that token on the state 11, right? Okay.